SpaceX successfully conducted a fifth test flight of Starship and managed to catch the first stage booster in mid-air back at the launch site. There's been a lot of stuff said already about this flight, and I don't feel the need to go over the whole thing in detail because a lot of it has already been said. But the aspect I have been getting the most questions about, and what I want to focus on here today, is that booster landing, or catch. Specifically, why a catch in mid-air rather than a landing on a drone ship or a landing pad like the Falcon 9? Did the chopstick arms really catch the spacecraft, or did it dock back at the launch pad? Why not use parachutes to slow the booster down? Why did it look like the rocket was on fire during the landing burn? I'm Swapna Krishna, and today on Astra, we're going to talk about that incredible return for Starship's first stage. I'm not really here to debate whether the test flight was a success, because I absolutely think it was a success. I don't really need to discuss that. That doesn't mean it was perfect, or that the ship is ready to be operational, just that for what they were trying to achieve, SpaceX nailed this flight. The two big things we were watching were the booster landing and a pinpoint splashdown of the upper stage. They both went very well. Now, there are a lot of people who have mixed feelings about SpaceX for myriad reasons, everything from the CEO to satellite pollution. So if you're wondering why this test launch in particular is important in terms of a broader view, well, Starship is crucial for NASA's plan to return humans to the surface of the moon. I'm not going to go over the ins and outs of NASA's Artemis program here. I have a video for that in case you need it. But NASA's current plan is to land humans on the moon in September of 2026. They likely will not make this deadline, but hopefully the landing will happen by the end of the decade. There are many reasons for the possible delay to the landing, but one of those is partner hardware. The Human Landing System, or HLS, is what will take humans from lunar orbit to the surface, remain on the surface during the landing, and then return the astronauts to orbit. HLS is a modified version of Starship. HLS will also need to be refueled in space, hence why SpaceX has been working on those demonstrations. The next one is currently planned for 2025, when two Starships will dock in orbit with one transferring propellant to the other. But back to Artemis. To be able to land on the moon, NASA needs Starship operational. I can tell you that they were watching this launch closely and likely breathed a huge sigh of relief here at the success. If you're still wholly unimpressed by this, I'm not actually quite sure why you're watching this video and made it this far. Hate watching will take years off your life, please don't do it. But I would tell you this to put things into perspective. Super Heavy is 233 feet tall, or 71 meters tall. That is taller than the average 20-story building. And they are sending it to the edge of space and then bringing it back down and catching it with mechanical arms attached to a launch tower. Now, let's go through this. I'm going to take you through the launch to the booster catch, speeding up some stuff, slowing down other stuff, but I definitely recommend watching the full video courtesy of SpaceX, which I will link in the notes below. And if you just want to skip to the analysis of the catch because you already know all this or you've watched a million videos on the flight already, I always have timestamps in my video, so feel free to skip ahead. Okay, here we go. You see Starship here on the launch pad. The upper stage Starship looks black here, while the booster Super Heavy looks white on the bottom, which makes it easier to see what's going on and what part of the rocket we're focusing on. Okay, here is liftoff. Everything is normal. You can see here on the left that all of the Raptor engines lit. So no engine failures for the booster on liftoff, which is great. The curving here is normal, pitching down range to cut through the atmosphere to get to the thinner parts of the atmosphere more quickly and using less propellant. The vehicle made it through max Q beautifully, still no engine failures. Max Q is the moment of maximum aerodynamic pressure on the vehicle, basically the moment where the launch vehicle is the most stressed, so always a sigh of relief when we make it through that successfully. One thing that's important to note is you can really see the blue methalox flame here in this shot. Without getting too technical, Starship uses liquid methane as a propellant and liquid oxygen as an oxidizer. It's more efficient and cleaner burning than the traditional liquid oxygen and rocket-grade kerosene that other rockets, including Falcon 9, use. I'll talk about methalox a little more later, but this is a great view of the flame here. Okay, the next big thing to talk about is stage separation. Starship uses hot staging. Basically, Starship, the upper stage, ignites its engines to move away from the Super Heavy booster before separation is complete. That's a tweak that SpaceX made after the first test flight when the two stages didn't separate properly. First, Super Heavy's engines shut down, which you can see here. This is what SpaceX calls most engines cut off instead of main engine cut off, the traditional term, because 3 engines remain lit. Then you can see Super Heavy separating here. The engines come back on. Starship's engines have also lit at this point. Now, for the purposes of this video only, we're saying goodbye to Starship, though it continued on into space for its suborbital flight and survived a re-entry and splashdown, mostly intact. And then after it splashed down, it exploded in a pretty spectacular fashion. That may have been a controlled detonation or a result of a fuel leak as it tipped over and fell into the ocean. But back to the booster. Here we are. Hot stage separation confirmed, and you can see all the engines lit up that are supposed to be lit up. Things are going well. At this point, the booster is making its way back to the launch site in Boca Chica, Texas, with the boost back burn. On every previous flight test for Starship, SpaceX has dropped the Super Heavy booster into the Gulf of Mexico. This time they wanted to land it back at their base, but it's not what you think of as traditional booster landing. Falcon 9 has basically defined what we think of as traditional, and frankly, people think of it as easy. It's not easy. The idea for Super Heavy is to maneuver it into place with what they call chopsticks, giant mechanical arms on their launch gantry called Mechazilla. Super Heavy has pins on it that you can actually see here in the video, and these are what need to slide into place for the giant arms to catch the Super Heavy booster. Before the booster could return, SpaceX had to perform automated checks on it to ensure that it was healthy and ready. When everything checked out, they sent the command for Super Heavy to try and return back to base. If it hadn't checked out, they would have dumped it in the Gulf and tried again next time. But luckily, the tower was go for catch. Here's the boost back burn. It's complete. All the engines are shut down, and you can see the thrusters on the side firing just to maneuver the rocket as it returns back to the launch pad. You can see the hot staging ring here falling away. Because they're trying to land the booster here, they jettisoned the hot staging ring. That's not new. That happened on the last test flight too. This is just to take off as much mass as possible while they're figuring out the booster's return. It's around 20,000 pounds. That's 9 metric tons, so it's worth shedding the weight. You can see the flaps here on the right maneuvering, and here's the pin again that I mentioned. One interesting thing here, this glow you're seeing is the engines themselves being very hot, not the engines firing. See, there's no burn happening. That's some immense heat from the friction of re-entry. We did learn after the flight that there was some outer engine warping from this heat. No huge deal, but interesting to see. Okay, so for the landing burn, it goes in stages, starting with 13 Raptor engines to slow down, and down to the final 3 engines. This will become important. This is where it gets really interesting. Look at this flame here. And from this angle, you'll see some black smoke as well. Super Heavy is maneuvering here. I know this looks really close on the feed, like Super Heavy is about to run into the launch pad, but if you look at it from other angles, which I'll show you in a minute, it is close, but not as close as it seems here. And success! Over the past couple of days, SpaceX has provided multiple camera angles for this, which has been really helpful to parse what's going on. Let's talk about that fire first. I want to flag that I talked with rocket engineer Gokul Das, who's worked on ISRO missions, to parse out what we think is happening in the engine compartment. Keep in mind that unless SpaceX tells us directly what's going on, everything you hear and see about this is conjecture. I've seen a lot of people talking very authoritatively about this, as if they know exactly what's going on. And unless they work for SpaceX or have heard it directly from someone who works at SpaceX, there's not really authority here because we just aren't entirely certain. But there is a lot we do know and quite a bit we can deduce. Here we see a better view of where that secondary fire is coming from, as well as the black smoke coming from it. This secondary fire, I think, is from fuel venting. Basically, the vehicle vents its fuel before the catch in order to avoid issues with overpressurization. Simple, right? Well, there is actually more going on here than that, in my opinion. When Super Heavy hits 1 kilometer, it starts its landing burn. That's 13 engines, 3 center engines, and the ring of 10 around it. That's certainly a lot of thrust to slow the rocket down, which they need to do quickly. But once they slow it down, that many engines are not good for fine control of the rocket, which is why they shut down those 10 engines after they achieve the desired deceleration, and we're left with those 3 center engines. But when those 10 other engines shut down, that's what Das describes as a flame foldback. Basically, when the engines are shut down, the flame folds back because of the airflow, and that may have ignited the methane, and because there's additional methane spewing around in the engine compartment, this might have ignited the actual engine compartment as well. There's been some speculation that there was more venting of fuel than was intentional, that it could have even been a leak and not just an intentional vent. My thinking was it probably was intentional. Maybe they vented more than they intended. I'm not sure they wanted it to catch on fire. It's not really a huge deal right now that it did. The black smoke is more complicated, simply because just burning methalox would not cause that. But because liquid-fueled engines take a while to shut down, you have to do it slowly, there's still a lot of methane as well as exhaust floating around. So as I mentioned, the engine compartment might have ignited as well. There may be something in the engine compartment that's burning to give off this black smoke, but we don't really know what. This is my suspicion only, but my suspicion is that it's some sort of thermal protection on the engines that's burning off. It's very possible that there's an internal fire going on that's charring through some stuff. It's not great, but this is a test flight. It's certainly not terrible, and I'm not trying to take away from the overall accomplishment. I don't want my focus in on this to be interpreted as this being a huge deal. I just was personally very intrigued by what might be going on here, and I wanted to dive in a little bit. This would need to get fixed at some point, but also, depending on what happened here exactly, the heating may not even be a huge issue. Raptor 3, the next iteration of the Raptor engines, don't actually require a heat shield. So this may all be a moot point because the internal plumbing on these will include regenerative cooling. These are currently in production, but also SpaceX does often overpromise when it comes to timing on these things. So I don't just want to say it's not a problem because Raptor 3 will take care of it very, very soon. But also, if the engine compartment catches on fire and the internal plumbing isn't well protected, and the Raptor engines are still cooled by methane as they are now, and that internal plumbing catches on fire, well, let's just say generally fires in an engine compartment aren't a good thing. And this is something SpaceX will need to look at. As far as the question of was this really a catch versus a docking, yes, it was a catch because the giant arms do move to grab the rocket. It's hard to see in that wide main shot, but in this other video SpaceX provided from the launch tower, you can actually see the arms moving to grab the booster. It is a catch. And the question of, is this mid-air catch all for show? Is this just something SpaceX is doing for theatrics? That's a hard no. This is actually a very smart and elegant solution to the problem of building landing infrastructure. The reason you can't use parachutes to slow the rocket down, and the reason they didn't want to land the thing on the ground is the same. Super Heavy is huge. Remember, it's like a 20-story, 25-story building. It does not have landing legs, and the amount of weight landing legs would add to the booster in order to be able to support its weight and any shock of landing would be, well, it'd be that much harder to make the thing land. Parachutes to slow it down have the same issue. Super Heavy is so big and so heavy, it weighs about 200 metric tons, which is about 440,000 pounds, as opposed to the SpaceX Crew Dragon, which is slowed by parachutes, which weighs around 12,000 kg or 26,577 pounds. Parachutes wouldn't really make much of a dent here. Also, parachutes are relatively inaccurate. They're fine when you have a landing zone a few kilometers wide, but they aren't super useful for a pinpoint landing at a launch pad. Plus, parachutes are heavy, and again, they don't want to add extra mass to the booster to make it even heavier. As far as why the rocket can't land on a drone ship or land like the Falcon 9, it can be hard to find precise numbers, but from what I can tell, the Falcon 9 booster weighs around 25,000 kg. The weight of the landing legs alone is 2,000 kg, or around 8% of the weight. You can see 4 of them here. Starship would need bigger ones, maybe more, 6 instead of 4, even making the legs as lightweight and strong as possible, which if anyone can do that at this point, SpaceX can, that's still a lot of extra weight. Plus, they need to be sturdy enough to support the weight of Super Heavy, which might mean making them even stronger and therefore even a larger percentage of Super Heavy's total weight. What's more, the landing infrastructure would need to be extensive. Landing infrastructure is often damaged by the rocket. It's not a huge deal with the Falcon 9 because it's not an especially powerful rocket. But Super Heavy is, and it could do a lot of damage to landing infrastructure when it's coming in. Not to mention stuff could get kicked back up and damage the booster. Super Heavy does have the ability to hover, which helps with the catch, but would also damage landing infrastructure even further if it hovered right above a pad. Falcon 9 can't get its thrust low enough to hover. This does mean, though, that Super Heavy can minimize shock absorption necessary for any landing structure, but the chopstick arms do have shock absorption built in. The idea for rapid reuse of Starship includes not having to refit the booster between uses. They want to be able to do basic checks on it and refuel it and then use it again, possibly a turnaround of hours, not even days. This is also where landing legs are a problem. On the Falcon 9, those landing legs need to be refurbished between uses. That means landing infrastructure that can handle a lot of use, as well as rockets that can land without damaging themselves or what's around them is really important. Catching the rocket in midair instead of letting it land on the ground protects everything on the ground while still bringing the rocket back straight to its launch site. And landing it back at that launch site means they can literally lower it to the ground, refuel it, and go. They don't even need to take the time to transport it like they did with the Falcon 9s that landed on drone ships. Before I close this video out, it's a long one, but I do want to mention that venting methane into the atmosphere before the catch, because that's an issue. Methane is a greenhouse gas, and while it's cleaner burning than traditional liquid oxygen and rocket-grade kerosene, I don't love the venting here for environmental reasons. There are other environmental issues to get into with Starship. The flame deluge system is currently under investigation, which is a whole separate topic, and this video is long already. I will cover all of this at some point. I want to point this out, not because it's a big deal now. This is a test flight, it's a one-off. Most of the methane burned off, whether intentional or not, though the byproducts of a methane burn-off are water and carbon dioxide, again, not great for climate change. But if we're talking about rapid reusability, if we're talking about sending Starship into the sky multiple times a week, multiple times a day, and landing Super Heavy back at the base, that's going to add up. And I didn't want this video to go by without pointing that out. I hope that's something that will get addressed because we don't need to add to our environmental woes with this. This might be the longest and also most specific video I've ever done, taking an hour-long flight and doing like one video about 30 seconds of it, but I enjoyed this deep dive quite a bit, and I hope you did too. But for now, that is all I have to say about Starship, Super Heavy, and SpaceX, at least until the next test flight. Thanks for watching. I am Swapna Krishna, and this is Astra.